Ladies and gentlemen, I'm Cathal Leigh-Doyle, a Senior Associate in Stephenson Harwood's Energy Practice, and I'm delighted to welcome you all to part 2 of our 2-part seminar series on hydrogen. I will start by saying how great it is to see such a high number of our Seminar 1 attendees returning today for this seminar. While a number of our attendees will know myself and our clients of Stephenson Harwood, for those of you who've not come across Stephenson Harwood before, SH is a full-service international law firm with over 1,000 lawyers based in our 9 offices around the world. Our international energy practice covers all forms of onshore and offshore energy, and we provide a full life cycle service from contracting, financing, transactional assistance to dispute resolution. As everyone attending here today will be well aware of already, hydrogen as a form of energy has been getting increasing attention, in particular over the last number of months, in nearly every sector and industry. When talking with clients and interested parties, the questions have quickly changed from can hydrogen be used in this way to asking where can hydrogen not actually be used. The UK government's 10-point plan, released recently in November, confirms that the UK government has clear intentions that hydrogen will play a major role in its decarbonisation story. While there are a lot of questions still to be answered by the UK government, we're encouraged to see the UK follow other countries by identifying and supporting hydrogen. Even quickly looking at other countries across the EU, you can see that hydrogen is being heavily backed by governments as a key component in their energy transition. If the green transition will radically transform, the green transition will radically transform how we generate, distribute, store and consume energy. And if the Hydrogen Council's recent estimates of the use of hydrogen going forward are anywhere close to being accurate, we will see just the amount of potential and commercial opportunities that exist in all areas. While everyone will understand the mammoth task the UK government has in order to meet their decarbonisation goals, it is widely accepted for the UK to meet their targets, private companies and private funding will play a large part of the business. The Hydrogen Council's conclusion is that there's already a number of no-regret moves and big opportunities, and I think our panellists today will agree and give all our attendees a great clarity on this point. From a commercial perspective, whatever your current role or future intention is in the hydrogen supply chain, there's no denying that it's an extremely exciting time to be involved in the sector. And we're extremely lucky to have 4 speakers with us today who will give everyone a multi-sector analysis of their experience in actually developing hydrogen projects. Due to the news breaking yesterday between RWE and Equinor, I thought it interesting to conclude this slide of their release just to show the size of the projects are increasing dramatically quickly as hydrogen projects become more mainstream. I appreciate there's a considerable amount of information I've just gone through as an introductory piece. However, I thought it important just to give the background before introducing our panel speakers today who will go into specific projects. I'm sure that our attendees today, you'll have already come across our speakers' projects. However, I think their personal insights into their journeys today will be extremely insightful and useful for all our attendees. First of all, we have Chris Jackson, who's the founder and CEO of Protium Green Solutions. Protium is a full support service for the deployment of hydrogen and fuel cell technologies. Chris is also the chairman of the UK Hydrogen and Fuel Cell Association. While Protium is directly involved in a number of confidential hydrogen projects, ranging in industry and size across the UK, Chris will take us through the HESCO contracting model and discuss the important issues he's seeing in his role as one of the UK leading hydrogen developers. We'll then move on to Julia Pyke and Shekhar Sumit from Sizewell C. Julia is a director of financing and Shekhar is a manager in the financing and economic regulation team at Sizewell C. Sizewell C is a proposed new nuclear power station in Suffolk, and they also have plans to use a spare low carbon heat from nuclear power to produce hydrogen. As we will discuss, Sizewell C recently issued an expression of interest in November, seeking to identify suitable partners to partner with them in the hydrogen demonstrator project. So we're delighted to be joined by Julia here today to give us their insights. And last but not least, we have Mark Griffin, who's the Market Business Development Manager at BOC. Mark is going to bring us through BOC's partnership with Aberdeen City Council, which successfully delivered one of the largest hydrogen refuelling stations in Europe. BOC was one of the first movers in the hydrogen mobility sector, and Mark will be able to give us an unmatchable insight into successfully producing hydrogen on a commercial scale. Unfortunately, Mark has been caught up and delayed in our meetings, and we hope that Mark will join throughout the other two presentations. Personally, I'm delighted to have the above speakers here with us today and thank them for their time and insights. In order to make the seminars useful for all our attendees, all of our speakers will have 15 to 20 minutes to discuss their specific projects. We've already received a high number of questions. However, if you have any further questions, please use the Q&A box at the bottom of your screen, and we'll endeavour to answer them throughout the presentation, or alternatively at the very end. Chris, the floor is yours.
Fantastic. Well, thank you very much, Cathal, and thank you very much to all of the attendees for joining, and to those of you who unfortunately have to listen to me again, thank you for your patience. As Cathal mentions, I'm the CEO of Protium. We are a green hydrogen energy services company. I'm also chair of the UK's Hydrogen and Fuel Cell Trade Association. For this particular discussion, I will be focusing on what Protium does and how we operate. We essentially operate as a project developer that is slightly different, I think, in our approach, and we're going to try and go through in the first few slides today a little bit about how we think about project development in the green hydrogen space as Protium. As Cathal alluded to at the beginning, a lot of our projects unfortunately remain confidential. However, we will be able to talk about conceptually how we do develop the projects we're working on, and also in the early new year we'll obviously have some more information we could talk about, and Cathal perhaps can try and find another opportunity to speak about those in some more detail. But what I'm also going to do a little bit once I've gone through the Protium concept is kind of put on my UK HFCA hat and my podcasting hat and talk about some of the other projects that we're seeing developed globally, and talk about some of the experiences and feedback that I've been receiving on those projects, so we can hopefully contribute to that broader discussion. So Cathal, if you can go to the next slide. So Protium is a hydrogen energy services company, and what we mean by that is that we see the development of green hydrogen, at least initially in the next 10 years, as being very much driven by specific clients. So unlike the conventional solar and wind market, where we seek to identify land and a grid connection and historically a price support mechanism, Protium specifically targets manufacturing companies, sometimes local authorities as well, that have ambitious decarbonisation goals. And we then basically perform two roles. One is as a project developer, identifying how we can build assets to achieve net zero for the client. And the other, in some ways, is a form of consulting role, which is working with the client to identify what their energy requirements are, and then building that into the project that we're developing. So we see these two things as having to work in tandem, and we think that that's the natural evolution of the project development model, and we see that as being the core to decarbonising a lot of sectors within the green hydrogen space. So how we think about this is we look at hydrogen as a multi-vector energy decarbonisation solution. So it's an opportunity to decarbonise power, to decarbonise heat, and decarbonise transport. And so we tend to think about how can we provide an opportunity that gives the long-term offtake structure that typically is preferred by institutional investors, so 15 to 20 years, but also benefiting from the fact that we can have higher margins in sectors like transport, which typically have terms of offtake that are too short for conventional project financing, perhaps 3 years, maybe 5, and if you're fortunate, 7. So what we try and do is develop a structure with a fixed offtake for up to 15 years for the provision of zero emission power, usually from dedicated renewable assets that we build ourselves, solar and wind, potentially with batteries. And then we also develop a green hydrogen production facility using electrolysis, usually behind the meter, potentially with a partial grid connection. And we then provide power and hydrogen for decarbonisation of industrial heat as our two main products under a 15 to 20 year offtake agreement. And we then look at also providing green hydrogen for commercial vehicle decarbonisation of transport fleets, and also for forklifts. So the idea behind this is that we create a special purpose vehicle for each and every client for the project, which Protium then develops and owns, and we bring in institutional investors at appropriate stages to build out the rest of the project financing. The idea is really to try and help manufacturers get over what we see as a huge impediment to the transition to net zero, which is constraints around capital. So for many manufacturers, the core driver around investment in low and zero carbon technologies is that they're thinking about things in the context of payback period, not is this a good NPV investment over the lifetime of an asset. So a project may have a very good NPV over a 15, 20 year period, but it may fail the 1.5 to 4 year payback requirement that many manufacturers have. And as a result, that structure, which influences a lot of procurement managers, tends towards very short-term decisions in capital investments and makes it very difficult in current frameworks to justify investments in technology like green hydrogen or fuel cells. Additionally, many power generating assets, solar and wind, are typically things that manufacturers don't want to own on their own balance sheet, and even local councils don't really want to own on their own balance sheet. So having another entity that effectively can provide services that help that client to get to net zero, but in many ways is almost treated as if they were being procured from a utility, actually makes the process far cleaner for them. Crucially, we think this then creates an interesting pathway for institutional investors to access decarbonisation. It is typically the case that for many investors that have been looking at how do they access industrial decarbonisation of heat, there have been very few opportunities to invest directly in those types of projects. Many have looked towards investments in gas utilities as one example, or tried to find energy efficiency as a service type models. We think a HESCO model, developing green hydrogen projects with companies, provides a relatively unique opportunity for investors to get involved and align their ESG objectives with net zero goals, and helping manufacturers to achieve their own objectives for their investors and clients. So that's an overview of how we think about projects. If you go to the next slide, Cathal, try and make this a bit less abstract. So when Protium works with clients, we work with our land agents to identify suitable land for the development of solar and wind. One of the things that's relatively unique about our model is that because we don't require the grid connection for sale of electricity into the grid, we can actually develop in a number of areas where conventionally solar and wind developers may have found good resource, but may have determined that the grid connection was too expensive at the time to justify. So suddenly areas of land that previously had been considered unviable for renewable development become viable to us under this model. We then look at providing potentially some power to certain clients where that's appropriate under a PPA structure, but the balance then goes towards the creation of green hydrogen. There's two key reasons here why we think having own dedicated assets towards the production of green hydrogen are important in the context of UK project development. One is this question around additionality. So frequently we hear from clients that they need to be able to demonstrate to their investors and to various groups like the Task Force on Climate Disclosures that they are generating or procuring additional renewable energy. And it's not sufficient simply for them to buy offsets or to buy credits. So by demonstrating that we have built additional assets that provide additional renewable energy, and that is providing these green energy services, we tick a very clear mandate box. There is no question that additional renewables have been developed, and therefore we are able to help them overcome that challenge in a way that actually a number of companies today that provide corporate PPAs for renewable energy are starting to struggle with. Additionally, there are a number of questions around regulation from government. So today, to benefit from a lot of the government price support mechanisms, notably the renewable transport fuel obligation around green hydrogen, it must be a dedicated additional renewable asset connected through a private wire for green hydrogen to qualify. And even if that does change in the future, we expect that at least this particular structure will remain relatively immune to potential changes in that policy because it is so clearly additional. So regardless of where government price support goes, we feel very confident that this particular project structure meets any and all of those requirements. And then depending on the client, we either provide a dedicated pipeline to site to blend for heat requirements, whether that's CHP or burners or boilers, or we provide hydrogen access onto site for things like forklifts and material handling. And so that's how we then envisage a HESCO style structure. Cathal, do you want to show the next slide? So unlike some of the other colleagues that are going to be on the call today that can actually show an asset, we have to give you a rendering. But this is just to give you a conceptual idea of a hydrogen production facility. Here we have two separate electrolysis facilities where we would produce hydrogen for our client. You can see sort of in the bottom of the image, solar panels, and this kind of is sort of some of the concepts we're starting to show and articulate with people. So, I mean, that at the high level is how Protium is working with projects. We're currently engaged with, I would say, 10 to 20 manufacturers in the UK and a number of local authorities. People who've been following our press announcements are also aware that we are doing some work with Zero Avia, hydrogen aviation company. So we're also considering how you can put together hydrogen infrastructure in the context of aviation, which we think is interesting. Increasingly, we're also looking to do some work supporting water utilities, where unlike an electrolysis approach, we actually are looking at the reforming of biogas and how you can use that for the production of hydrogen. And with another one of our partners, Cambridge HOK, trying to understand whether heat generated from reforming and CO2 from the reforming of biogas can be used to support a circular economy story, such as greenhouses or things like vertical farming, which are areas of interest that are gaining a lot of attention in the context of how the bioenergy sector can interface with the food system more broadly, and also decarbonisation of end users like transport and heat. So that is Protium. I think what we said now, Cathal, is that we'd sort of go on, as it were, and show a couple of examples of other types of projects that are being developed, just to give a little bit more of a flavour. So if you go to the next slide. So one of the things I like about this slide, this is a 20 megawatt solar PV project with a 10 megawatt electrolysis facility in Japan. And these are the sorts of project sizes that Protium is currently developing. So we are looking at projects really between 20 to 50 megawatts of our own dedicated solar assets, and minimum electrolysis side really around 10 megawatts up to 40 megawatts. So just to give you kind of conceptual layout of how large these types of facilities look. Carl, if you go to the next slide. And then kind of giving you a little bit more of a ground level. So these types of projects at the moment that are being built are feeding directly into the grid. So, you know, they'll generate green hydrogen and then they'll either blend it with natural gas in the grid or they'll be used for transportation. Carl, if you go to the next slide, please. A similar example of this is the Energy Park in Mainz, which probably anyone who's been in the hydrogen space has seen this one to death, but it's still a good slide. It's about a 20 megawatts onshore wind farm in the background, alongside 6 megawatt of PEM electrolysis by Siemens. It's been running since 2015. And then if we go to the next slide, so this is then a slightly different approach. So many of you will be familiar with the HyNet project, but I don't know how many people have actually seen sorry, go back, Cathal. One back, Cathal.
Sorry, it's got a mind of its own there now at the minute.
No worries. So, I mean, the two slides that we were showing there of Japan and of Germany are pilots. And as I've been fond of saying to people, we're sort of moving out of demos and we're moving towards deployment. You know, I think those are useful though as examples of showing people how these types of structures have been put together so far. The image we were trying to show before, and hopefully Carl will come back to, though, is a project that's slightly different from what Protium does, but I think is probably interesting for this conversation, which is blue hydrogen and the context of large-scale carbon capture and SMR. So the image before is the Liverpool area around a project called HyNet. Many of you may be familiar with HyNet. It's being led by Progressive Energy and by Cadent, with support from a number of entities, including Johnson Matthey. One of the things that's interesting in that particular context is the timeline around deployment of blue hydrogen projects as opposed to other types of hydrogen technologies, and something I'm sure we'll get later into in this discussion. But if you were to look at the timeline for these projects like HyNet, or even to look at Acorn, which is another project for blue hydrogen, from start to end, we are looking at a sort of 4 to 7 year period really to get to financial close from initial concept. And I think that's the thing that is in many cases in this discussion around the timelines around hydrogen is missing. It's certainly in the context of green hydrogen, most projects from initial conception through to actual deployment, especially if you're going through planning and permitting for additional renewables, can be at the earliest and best case 2.5 years, but in reality between 3.5 to 5 years to deploy. So when people are talking about hydrogen deployments right now, and they're talking about sort of the large scale expansion of hydrogen, whether it's green or blue, it's important to recognize that it probably will still be another 3 to 5 years before many of these projects become a reality. The project that's being put in front of you here, by the way, because I think Carl's not be able to go back to the HyNet one, but the one in front of here is one that I just put up because it shows that sometimes the way we think about projects in Europe is not necessarily the same as we think about projects in other markets. So this is in Costa Rica. This is a project run by a company called Ad Astra. They basically have taken, and people might not be aware of this, in 1991, there were 20 fuel cell buses that Vancouver ran for the, I think it was the Winter Olympics over there, and one of them happened to make its way over to Costa Rica. And so the team from Costa Rica put together a solar PV and electrolysis project, and that now provides hydrogen for a number of Toyota Mirai fuel cell electric vehicles that run for a zero emission eco hotel, so that they can do leases for tourists that want to drive around areas of zero emission, but also for local buses where the grid's really not strong enough in most of rural Costa Rica to be able to provide charging. So these types of projects in developing countries, I think, are just a little bit different to what we often see in markets like Europe and indeed in North America as well, which tend to focus more on decarbonization of industry or on decarbonization of large fleets. There are also different models in different markets that we will see. Cathal, I don't know if we're able to go on to any more slides. I think we may be stuck here.
I am hoping that Anusha is going to take control here, because for some reason, there we go, perfect.
Okay. No, and then just from the sort of relatively small scale projects we were describing to sort of the relatively ambitious ones. Again, something that's interesting here is the time frame. So if you look to the right, the Asian Renewable Energy Hub, this is a project that has been developed now for sort of the better part almost of a decade. It's a 25 gigawatt solar PV and wind project, which at last count was somewhere between 10 and 12 gigawatts of petrol electrolysis into green hydrogen and then green ammonia for exports into Europe and Asia. These types of projects have an unbelievably long lead time, and critically to some of these discussions, there is also this question around, in the early part of my presentation, we were looking at decentralized hydrogen production, but longer term, there will be a need for larger scale imports and exports of hydrogen, and understanding that transition from when we go from a decentralized model for the majority of hydrogen production towards an import and export starting to have a bigger impact is really critical. And the image to the left is also just showing how some of those questions are starting to play out in other big markets, like, for example, Africa, where a group called the African Hydrogen Partnership, in collaboration with the EU and others, has been looking at how do you decarbonize, or how do you ensure that energy infrastructure being built inside markets that still have growing energy demand and a growing need to decarbonize is capable of meeting that. And it typically starts with local hubs in the black dots that you can see, and then builds out. So just, again, trying to give people a flavor of different styles of project development and different styles of how people are approaching projects in the context of hydrogen, whether they be very small for very local issues, or whether they be on a continent scale, looking at hubs or large scale imports and exports. Cathal, I don't know if there's any more slides. I think there might be one more, but otherwise I think we're there. Yeah, and then, just trying to point out again that we've seen a number of renderings from organizations about what they're looking to do, but it's no longer just the sort of Nicholas of this world that are looking at it. This is a slide from Infinite Blue Energy in Australia, looking at one of their projects that they're trying to develop there. From Arrowsmith, that's a $1.5 billion Aussie dollar project. But within a 4-year period, Infinite Blue Energy's put together a pipeline of nearly 6 billion Aussie dollars worth of projects. Indeed, I think Australia is actually now over 20 gigawatts of green hydrogen projects under consideration, really all within the last 3 to 4 years. So the market's moving very quickly, and it's evolving in different spaces. But it's just interesting to think about why and how those can work differently. And in many cases, it is all to do with timelines, planning, permitting, and what people perceive to be their end market. So where people are seeing an export opportunity, they've been able to develop larger projects earlier. Where people are looking at local demand is a more decentralized model. And then those timeline considerations become really important. So I think I'll stop there, Cathal, and then if there are questions at the end, we can go through those.
Perfect, Chris. Thank you very much for that. I think I'm just going to jump in with the question straight away, because you were intended to go last. However, we put you first and on the spot, so thank you for that. But from your perspective, are you seeing specific sectors reaching out to companies such like yourself, or is it a complete spectrum that you are seeing from the attractiveness to hydrogen and even the inquiries into hydrogen?
So I think where we are seeing a lot of interest at the moment, and it will be very interesting to see what happens after. So tomorrow, for people who aren't aware, is when the 6th carbon budget comes out for the UK. The Committee on Climate Change will be releasing. So that will give kind of a big steer as to where government policy will go, and potentially inform then COP26. But what we are seeing is that even without that government push at a corporate level, there are so many organizations and even local authorities that have made very bold ambitions, such as net zero 2025, net zero 2030, or even net zero 2035. And they're now looking at what the practical realities of that are, and those practical realities are significant. If you're thinking about decarbonizing industrial heat, the reality is that there are few well-known, well-tried and tested air source heat pumps or ground source heat pumps that you can easily deploy without significant modifications into an industrial site by 2025. And you're still paying the full grid price. So that doesn't give you a huge amount of time to be thinking about what your other options might look like. And equally, even on the transport side, people who are thinking about decarbonizing their transportation fleet, or who are operating in cities like London with ultra low emission zones, are looking at the models available in the market and realizing that unless they're proactive in pushing companies and saying this is what we need, that they're simply not going to have the vehicles required, and they're not going to be in a position to make that transition. So that is definitely happening. And I would say consumer facing businesses are probably the most exposed to this. I've been slightly surprised. I'm probably quite controversial for saying to a few people that I don't understand why the focus has been so often on steel. Steel has a huge amount of emissions. Absolutely, there's little arguing with that. But steel is such a energy sensitive commodity. Energy is such a huge part of the steel making process. whereas for a huge number of consumer-facing manufacturers, energy is barely more than a few pence on a product, and the marketing budget could be, orders of magnitude 10, 20, 30 times the energy cost on each product. So actually being able to say you're zero emissions and that you're contributing towards the fight against climate change, those drivers are leading certain companies towards these solutions. And I think that's where we've seen a huge amount of interest.
Very good, and thank you for that, Mark. I'm going to welcome you to the panel, and thank you for joining. You've missed your own personal introduction, so I'm going to let you jump straight in. And the floor is yours, Mark.
Thank you. Can you all hear me now?
Perfectly.
So I'm Mark Griffin. I'm the Market Development Manager for Clean Fuels at BOC. So my role is to manage our existing assets, which I'll come to talk to you about, our Kitty Brewster station in Aberdeen. But I'm also there to develop new opportunities, and that goes from working with individuals who've got aspirations of utilising hydrogen as a fuel, all the way through to fleet operators and even city regions who have these now decarbonisation strategies and commitments that they need to make. So I've got the opportunity today to talk to you about our station in Kitty Brewster in Aberdeen. So this station was originally, just to give you some background, this station was part of a funded project. Yeah, to give you a background, so the station was part of a funded project called High Transit, which was funded by a number of different funding organisations, including the FCHJU. And what this was looking to do was to bring forward a bus refuelling station. So it's supported with funds for 10 single-decker Van Hool buses, along with the hydrogen infrastructure with on-site electrolysis. And this was really about Aberdeen being able to support obviously what they'd seen and gone through with the dip in the oil and gas industry, and about how to future-proof themselves as well, and they've really got behind hydrogen. As you can see here, we have a number of funding from Innovate UK, from Scottish Government, from the FCHJU as previously mentioned, and then also local funding as well from Aberdeen and the bus companies towards the vehicles. Next slide, please. So, and then we had the project partners, and this is a key part of what we're doing going forward as well. So, BOC were the lead on the High Transit project. So we were coordinator and also the provider of the refueling infrastructure. We had we had a Stagecoach as the bus operator, and the local authorities, Aberdeen City Council. There was the bus technology, which was a combination of the fuel cell from Ballard and the bus from Van Hool. And then we had Planet and Element Energy, who were collating all the data and analysis. And then we had a dissemination partner, which was Hire, which was really, really important. And for those who have been to Aberdeen, the general awareness around hydrogen and what the city's trying to do is very well known, and it's part of an everyday conversation that you can have with people in Aberdeen. Next slide. Thank you. So this slide, in its current format, shows where the Kitty Brewster station is, and the premise for this slide was to show you that you don't need to have hundreds of meters of space around a refueling, production and dispensing facility. At Kitty Brewster, we're actually on the bus MOT land, but we're only a short distance away from the mainline railway station, from local residential and businesses, and only a few metres away from the pavement there close by. So one of the key messages that we want to get across is that we can build these and situate them in places where you would normally put a traditional refueling station. Next slide. And this is what the refueling station looks like. So the great thing about this is we put fencing up to protect the public and obviously to prevent anyone from gaining access, but we can also use it as a really strong dissemination tool. So we can tell people that are driving past, whether they're locals or whether they're visiting the city, that this is a hydrogen refueling station and these are the benefits. And the image on the right shows that another ambition or output from the design phase was we want the dispensers to look like traditional dispensers. We want the user experience to be as close to what they used to currently, to avoid any refueling anxiety when it comes to new people with new vehicles. Next slide. Thank you. So as you can see there, we run out of budget for models, so I kindly stepped in at the last moment. But the key thing here is just to really push on the messaging side of things. On that left one behind myself, you've got the project partners, you've got the funding bodies, so people know who's involved and how they're committed. And then on the right, it's some awareness of how we produce the hydrogen and the benefits of producing the hydrogen as part of that, basically, of that hoarding as well. So we found that as a really useful tool. Next slide. And then we look at how the station is designed. Now, normally we would have a nice image here, but the importance of system design is really important. When we designed the station at Aberdeen, we knew what the total daily demand was, but we didn't factor all that into a single electrolyser, a single compressor and a single dispenser, because not only during times of planned maintenance, but also of any downtime, if you have twin streams, then if you take one electrolyser down and one compressor, the other two electrolysers and the compressor in this situation can continue to work in order to produce the hydrogen for the refueling that will happen in the evening with the buses. And this has been really fundamental to the performance of the station, which we'll come on to. The station is currently operating at 99.6% availability, of which there's been no failed refuels. And that's really important when it comes down to the design. And can I have the next slide, please? And again, this just goes to clarify. So we were aware that the buses were going to come with a 30 kilogram tank. So we ensured that we had 360 kilograms of production capacity. That actually went down to an average of 20 kilograms a day, but there is a 30 kilogram tank, which helps with design. We had 600 kilograms per day per compressor. We had 460 kilograms of on-site storage. We designed the solution to have a 6-hour refueling window, and we ensured that we had twin dispensers so that we always have that redundancy in the solution. Next slide, please. And there's some other key factors which has helped with the success of the station, and that's around having local operational and engineering support. This has been, I think, really, really key. And in turn with that is the local provision for parts. We've seen in some instances where if you've had to order a part and it's on a lead time, a 30-minute fix becomes a week-long problem, which where you look at it from bus availability perspectives, this has real knock-on effects on the availability of those vehicles to perform the service. We also have a hydrogen plant monitoring service. So this allows either the local operator or Lindy or BOC to be able to dial into that station. They can see how it's performing. They can look at all the data behind what it's been doing. But just on a more day-to-day basis, they can dial in at 7 o'clock at night and check that the station is ready to commence the evening's refueling. And then they can also dial in at 7 o'clock in the morning and see how that previous night went and make any amendments, but if nothing else, be able to certify that all 10 buses arrived and all refueled and all drove away again. And another important element to the solution is we have a planned preventative maintenance software program. So all the data of all the elements are factored into the system when we design and when we're building the system, and then it automatically updates with when the next service or the next change or check needs to be done. And this means that the local engineer or the operative in the Aberdeen case will dial in and it'll say, right, in 2 weeks' time, you need to go around and check all the pressure relief valves. And he'll plan that into the work pattern so that we either do that prior to it being required or we do it in time for it when it's required, so that we allow the station to stay at its peak performance levels. And another thing is that this is a new process, so we understand that when people are learning, that they understand it. So training's delivered to all new users of the station, whether that be new bus drivers or whether it's other vehicle users. But we understand that sometimes the system's an intelligent system. So if you connected up the system, but there was a fundamental error in that process, you'd go to press the green button and it would basically beep and say that there's an error. So go back through that process again. So there's a visual aid on the dispenser which says this is the process. So it just helps with that education and that familiarity, so that you don't end up with a negative experience, that you can go back through that process, you make the correct seal, you push the button and it refuels. That's been really key. And then next slide, please. And this is a really important one because this gives you some real strong data in regards to what that impact has been for Aberdeen and for that particular bus service. So the vehicles themselves have driven over 1 million miles, of which carrying over 1.6 million passengers. The station's delivered over 160,000 kilograms of hydrogen and an average refueling time of 10 to 12 minutes per bus. The buses have been able to travel on average 260 miles on a full tank, and this has saved Aberdeen over 100 tonnes of CO2. And again, with a station there with above 98% availability. And this is a really important message. This is just a small single fleet of buses. The ability to adopt this hydrogen and other zero emission technology means that we can do this in greater scale. And the next slide, please. And on the back of the success of the original design, in 2017, we opened up the station to have additional 350 bar refueling for vehicles such as vans, road sweepers, RCVs, and also 700 bar refueling for cars. And this was done because of the way we designed the station. We could introduce this additional capacity and access to the station without having to create massive changes or capex inclusion in the station. So Aberdeen now has 60 non-bus hydrogen vehicles, which has all come from various funding streams, but also by having the hydrogen available has helped people, whether it be public or private businesses, look to adopt the vehicles that are available and help them to decarbonise their fleets. And as you hopefully will have seen recently, the original 10 Van Hool buses are now being replaced by 15 double-decker Wright buses. So that's the advancement in that 5-year period from 2015. We've not only seen those other vehicles come, but we've also seen developments in the bus industry as well. So we've gone from single-decker hydrogen buses to double-decker. And the great thing about that as well for the UK is that we've now got 3 UK bus manufacturers as well that have a hydrogen option, which is really, really exciting for the future. Then we've just got the last slide, Cathal, but it's just a holding slide to say thank you very much. I appreciate it's a bit of a whirlwind Aberdeen, but I think the key message from this is that this is not a concept. It's being done. It's being utilised. It's being used in a commercial setting in Aberdeen. The funding period closed in March last year and has continued as a commercial operation with all those vehicles. So the funding is an important part to help get these projects up and running. But if we can build them in the right way and see the type of adoption that's happened in Aberdeen, they continue and become very sort of mainstream in the future as well. Thank you.
Very interesting, Mark, and thank you very much for that. I'm going to lead before we go to Sizewell C, just with one question, Mark, because you mentioned, and I no doubt it'll come up in the Q&A again, but from the system design, BOC were in a unique position that they knew the total consumption that you were aiming to achieve with you in your hydrogen production. And as the projects get bigger and hydrogen becomes more mainstream, how do you think BOC and other potential producers will deal with the unpredictability in your systems design, because you won't, well, I presume you won't have a total consumption figure you're aiming for your system designs in the future?
That information is getting a lot better. It's getting a lot better. We're seeing now sort of route shadowing and some route analysis that allows you to get a fairly predictable rate of hydrogen. But also we're now looking at larger schemes. So like saying with the city region approach, that like Aberdeen, they're now mapping out how do they decarbonise all their vehicles. And you're right, in a way we have to make some assumptions, but that can be based on how much renewable energy is available, how many vehicles, and do that. But we always plan with future design in mind as well. We don't want to get to the point where we need to add because there's been an uplift in vehicles or it's taken off faster than we predicted if we were doing phased introduction of the production and the refueling, to find out that the issue becomes footprint or grid capacity, for example. So we have quite a lot of information on sort of average consumption rates on different vehicle types. And we try and work very closely with the vehicle manufacturers as well to sort of understand what their kilograms per 100 kilometres rates would be and things like that. And work in the range. They can generally be within 1 to 2 kilogram ranges per 100 kilometres. Perfect.
Thank you. And last but not least, we move on to Julia and Shekhar from Sizewell C to talk us through their demonstrator project. Shekhar and Julia, we'll keep control due to the technical issues we've had so far. We'll keep control, so we'll try minimise any disturbances on that.
Thanks, Cathal. So can we go on to the next slide? So Sizewell C, why am I here talking about a nuclear project at a seminar which is about hydrogen? And the answer is because to make hydrogen, you need electricity, and you might also want heat to make it more efficient. And because Sizewell C is going to be a 10-year construction programme in which we're going to look at how we can use hydrogen to clean up the construction and also to help the market in hydrogen construction vehicles and plant develop in the east of England in particular. And it was really interesting listening to Mark talking about the practicalities, because that's exactly the sort of thing we need to know and to study so that we can understand the impact on construction productivity of moving over to hydrogen versions of construction plant. So very briefly, what is Sizewell? Where is it? Where are we? It's a proposed nuclear power station on the Suffolk coast next to Sizewell A and Sizewell B. It will supply power to around about 6 million homes, so electricity. It will generate electricity for around about 60 years. And in operation, it will save around about 9 million tonnes of CO2 for every year that it's operational in comparison with burning gas. And it will support 70,000 UK jobs. And if we can, and where we are at the moment is we submitted our development consent order earlier this year. We've applied for our nuclear site licence. Our early works are ready to go. And people will have seen that large-scale nuclear is featured in government's 10-point plan and in the National Infrastructure Strategy. So if we go on to the next slide, nuclear and hydrogen. What nuclear is a massive heat machine. So although in the UK that heat has always been used for providing electricity to the grid, we are looking at actually taking some of the spare heat and using it for other purposes. So we only use between 30 and 40% of the heat that we make to make all of this enormous quantity of electricity, and the rest of the heat is effectively spare. So we've been looking at how can we use it. And some of the ways we can use it are for heat-assisted hydrogen, which essentially uses less electricity and therefore will be cheaper. To power direct air capture technology, so make the project carbon negative, give a few industries a bit more room to continue emitting CO2 where they're particularly hard to make net zero or CO2 free. We're looking at thermal storage, we're looking at synthetic fuels, and obviously we're looking at using the heat itself in the form of district heating. Something that's very important to understand is that nuclear heat in other countries is piped up to around 80 kilometres. So we're not talking about having a big hydrogen plant right next to a nuclear power station. We're talking about locating it a few kilometres away, probably a bit further up the coast. And on the right-hand side of the slide, I've just shown a picture of electricity demand and generation in July this year, when over the summer we had a period of particularly low wind. And what you can see in this picture is the amount of unabated gas, which we absolutely have to stop burning, and whether or not we are achieving that through CCUS and actually abating the gas emissions, through increased development of offshore wind and solar. You can see that we have quite a significant challenge ahead of us. Although the UK has done well in decarbonising the power system, it hasn't done nearly well enough yet. What you can also see in that picture is that the nuclear is providing a constant load along the bottom. And one of the reasons that that is so constant is that the old nuclear power stations, the ones which are closing down over the 2020s, are quite inflexible, but new nuclear power stations are much more inherently flexible. And so the question really is whether or not the society is going to want the nuclear to operate flexibly, or whether or not in fact it would prefer that on windy days the electricity and heat was diverted to make hydrogen and store that for days where there's a shortage of wind, rather than to operate the nuclear flexibly in response to weather patterns and demand. So if we go on to the next slide, how can we use hydrogen in construction? So Sizewell, as I said, will have a construction period of around about 10 years. We want to future-proof that against the increasing costs and restrictions on the use of diesel. We want to clean up the construction. We want to obviously minimise particulate emissions. And so we've been looking at putting a small electrolyser powered by Sizewell B, which has nice, constant, low-carbon electricity. And we've just given some figures to make this a bit more real for people. What could you do with the 2 megawatt electrolyser? You could make enough hydrogen to power 16 buses, or 160 cars, or 4 trains. We will use at peak construction around about 200 buses. And so we are going to look at doing making hydrogen in a way which is scalable for us, so that we can actually meet peak demand if that turns out to be what we want to do. And we're also very interested in helping to kickstart the local hydrogen economy in the east of England. So Sizewell C is near to ports, it's near to Felixstowe and Harwich, Ipswich and Lowestoft ports. We're interested in helping to develop a market in providing clean shipping fuel. The east of England train service is actually one of the first, which is slated to start using hydrogen. And we're interested in industrial and agricultural uses of hydrogen. Suffolk is a very rural county, and working with the landowners is very important. And as farmers lose access to things like red diesel, then we're interested in whether or not we can help them start to move over to use more hydrogen. Then if we go on to the next slide, just briefly before I hand over to Shekhar. So that's what we want to do in the short term. In the longer term, we're very interested in making a lot of hydrogen. Just a statistic, if you dedicated the whole of Sizewell C to making hydrogen, which is not our plan, we're planning to make electricity as well, then Sizewell C would make more hydrogen than is made in the UK today. So this is something which can make a huge difference at scale. And when you're thinking about future nuclear plants and thinking about what you want them to do, then making hydrogen is something to very much bear in mind, because if you use steam-based electrolysis, it's thought to be what it is, more efficient, uses less electricity, therefore it's likely to be cheaper. We are closely following a project in Germany which uses solid oxide electrolyzer cell technology, and we are interested in how we can supply heat and power and possibly hydrogen into free ports, and we're very interested in powering direct air capture machines, but that is of course a topic for another day. So I'll hand over to Shekhar at this point.
Good afternoon, everyone, and thanks, Julia. Thanks, Cathal. So as Julia was saying, one of the visions that we have is to drive this hydrogen ecosystem forward, as in both in the short term, medium term, as also in the long term. So in the short to medium term, as Julia mentioned, we are looking at this small scale electrolyzer. And this electrolyzer, we are looking at utilizing either an alkaline or a PEM-based technology to drive this 2 megawatt process forward. And the principal use case for that would either be, as Julia mentioned, to drive forward Sizewell C construction. So be it hydrogen powered buses, AGVs, or say, for instance, hydrogen gensets at the construction site. So that would be one use case. But at the same time, the other use case also, which we have in mind, is local stakeholders. So we've already had a number of discussions with various local authorities who are also similarly interested in making use of hydrogen that we may be producing. So where we are looking for refueling facilities, we would be looking at refueling facilities which could hopefully service both the Sizewell C construction needs, but also needs outside of Sizewell C. So that is one aspect of what we are looking at. The second aspect, again, as Julia mentioned, is just in terms of where we are, geographically speaking, we see a number of synergies going forward. For instance, we are not that far away from the Bacton terminal, which could become a major hydrogen reception processing center in the time to come. And also we are proximate to ports such as Felixstowe. As a number of people on this meeting, maybe were already, the government issued the free ports bidding prospectus recently, and decarbonization is one of the main objectives outlined over there. So again, there are clear synergies which are looking in that regard as well. We are also not that far away from offshore wind. So again, if you think about a situation where hydrogen generation is powered by intermittent renewable technology, but also at the same time you have, say, for instance, Sizewell C providing firm supply at times of intermittency, then that again could be another synergistic application going forward. So in a nutshell, just at a high level where we are right now, we think there are a number of potential avenues to be explored going forward, both in terms of the smaller scale electrolyzer as also the larger scale plant, which would be coinciding with the operational Sizewell C project. Cathal, if we could go on to the next slide, please. Thank you. So on this slide, we have just tried to provide a very high level overview in terms of where we are right now in 2020 and where we hope to be in the year and the decade to come, in the years and the decade to come. And essentially what we see is, so there would of course be a use case in relation to the Sizewell C construction site. So that is one use case. There would be external use cases, but at the same time also, very interestingly, we also have some internal use cases to do with hydrogen at nuclear power projects. For instance, there are actually two fairly specific uses to which hydrogen is already used for in nuclear power stations. So first of all, hydrogen is used as a cooling medium in respect of the turbines, which actually power a nuclear power station. And secondly, even in terms of the actual reactors themselves, which are surrounded by coolants, hydrogen is actually used to enrich that water so as to ensure that the coolants remain fit for purpose. So there are actually some internal use cases as well in terms of hydrogen, not only at Sizewell C in the years to come, but also currently at Sizewell B, which we'll be looking to tap into, in addition to, of course, the entire construction case, which we were discussing earlier. Cathal, if we could move on to the next slide as well. So currently, where we are, particularly in terms of the small scale electrolyzer, is we issued an expression of interest, which went out on the 23rd of November, 2020, just a couple of weeks back. And what we requested interested parties to come and speak to us about essentially were three lots. So the first lot is in terms of the actual hydrogen kit itself. So the actual electrolyzer, the relevant associated infrastructure, including the refueling facilities, and also the case for operation and maintenance of that electrolyzer. The second lot is in terms of the consumption in respect of that hydrogen to be produced. So the consumption, one part of course is in relation to be it buses, AGVs, or hydrogen gensets, and we'd be interested in speaking to vendors and manufacturers and suppliers who have expertise in that regard. But at the same time, also if there are any other stakeholders in the region who would be interested in potentially purchasing this hydrogen for their own purposes, again, we'd be looking forward to speaking with them as well. And the final lot, which we have over there, is just in terms of project management services, which as in just to drive the project forward in conjunction and support with us. And also, as Julia was mentioning, in terms of where we are looking to site this particular hydrogen electrolyzer, we do not envisage it being sited either on Sizewell B land or on Sizewell C land. It probably would be at a slight distance away, but we envisage it being powered by electricity which is drawn from Sizewell B. So the closing date for that expression of interest is 8th of January 2021. So actually just exactly about a month from now. So if this is of interest to anybody on this call, please to get in touch with us. But what we see this project as being is essentially in the short term, driving construction at Sizewell C in a green, sustainable manner with the support of hydrogen. But in the longer term, we envisage a much larger scale hydrogen powered by steam, as Julia mentioned, where we can hopefully tap off the substantial amounts of heat from Sizewell C to drive that process forward. Thank you, and very, very glad to take any questions at all.
Julia, Shekhar, thank you very much for that very insightful and well, as everybody on this call is doing, is market leading insight into the area, and it leads on very, very well into the first question, and it comes around collaboration. There's been a lot of discussion across the hydrogen market for the last number of months of how important collaboration is. Now, we all know it's a competitive market, but essentially, Sizewell C is at an interesting stage where it's just issued its expression of interest and is looking for the potential. So I might orientate this towards Chris and Mark. How have you found the experiences to date in relation to two aspects? One is the collaboration with the supply side, and also then on the consumer side, because a big question, and Mark, it goes back to my original question on system design, knowing who your ultimate consumer is going to be. Shekhar mentioned that he'd have, they've identified the current and short-term uses, but also the long-term perspective. So I put that to Chris and Mark.
Mark, do you want to do the honours?
I think collaboration is key. It is absolutely key, and it's understanding what you bring, what the market need is, and then understanding what you need to bring together to deliver that. And with, like saying, from the Sizewell C, it's about understanding that they've got the power, and then they need the electrolyzer and the infrastructure to go with that, and then they need the users, because again, it's a relatively small scale project, but it's there to test all that, and then the fact that everything is scalable on the back of that, then it leads to larger projects as well. And I think collaboration is truly key for this industry, given the time frames and the scale of what we've got to achieve.
I guess maybe not so much, maybe collaboration is a strange way of me phrasing this next, but I would say, even though it's a competitive market, there is very much a sentiment of a rising tide lifts all hydrogen ships in this context, because the fact that I was able to show some images of other projects is actually helpful, because the fact that companies like POC or Rise or others are able to go out and put assets down makes it easier for new companies coming into the space to demonstrate that it's been done, to point to examples like what's been done up in Aberdeen and say this is not this is not a demonstration, it's been done, it's commercial. I think that very much is kind of where there is a bit of collaboration where people are kind of showing off, if you like, what their competitors are doing in a way, because there's an incentive for everyone to show that it's being done safely, that it's being done commercially, that it's appealing. So I think there is a lot of collaboration there. I think, you know, as the market is maturing quite fast, you probably will see more competition, but it's, you know, it's what I'm trying to avoid, and what I think most people are broadly avoiding, is friendly fire. It's early days in the industry, and quite often there is a tendency in early stages of industry for people to get a little bit too competitive before the market's really taken off yet. And I think people are acutely conscious that we had a significant hype cycle around hydrogen in the late 90s, early 2000s, and the last thing that everyone wants right now is for this to kind of be a similar scenario where everyone gets very excited, but actually spend more time criticizing each other and each other's respective models, rather than just focusing on heads down, get your projects done. If someone's doing something that you can kind of help promote, then great, do that. Yeah, and do come and ask people for questions, right? I mean, I think that's where grants have also been quite helpful. There's absolutely no doubt that a lot of the grants, because they have required companies to make information public that probably wouldn't otherwise have been made public, there's a huge amount of knowledge in terms of some of the commercial structures, some of the safety risks, some of the resiliency, redundancy, some considerations around planning that have come up, and has made it considerably easier. And, you know, BOC's work that Mark's been involved in is a really good example of some of that. But, you know, even things like some of the planning application submissions, you know, people had no idea what a hydrogen planning submission looked like in the UK. There are currently, to my knowledge, 6, if you really look and you know where to look to find in the UK, but they are hard. But the fact that they exist gives you something as a reference point, whereas if you'd gone back 5 years ago or 10 years ago, there were none. So there's definitely collaboration in those elements, and that's definitely helping people.
Mm. Thank you. Julia and Shekhar, the one issue which we've received a number of questions on is in relation to costings. And as everybody knows, the cost model shows that the capacity factor is going to be one of your biggest drivers of hydrogen production costs. And there's been recent publications, I know in September, Lucid Catalyst reported that they're estimating a $1 per kg based on new, and that's the shipyard-based manufacturing from nuclear into hydrogen production. And I'd just like to get your perspective on how you're dealing with your cost modelings. And I know you've got the Demonstrator project, but are you looking even further afield already at your cost modelings from nuclear, or how are you dealing with that?
Yeah, well, I'll answer very briefly. The predominant cost of nuclear to consumers is the cost of money, because we have a long construction period. So if people think about Hinkley costing £92.50, which is much reported, £11 of that is the cost of construction, £19.50 is the cost of operations, and the rest is the cost of money. And the cost of money breaks down into two elements, roughly. One element is the amount it would cost were it financed on a sort of normal regulated asset-based type basis, and the rest is the cost of risk. So doing something for the first of kind with all risk sitting with the developer. So the idea is that with Sizewell, the government's been looking at financing nuclear as a regulated asset, and that will bring for Sizewell, we think, the cost of the electricity to the consumer down to between 40 and 60. The variation isn't really to do with our own construction cost estimates. Again, construction cost is actually a relatively small part. The variability is to do with how much risk the government chooses to put onto the developer, and therefore the cost of capital. So if Sizewell is producing electricity at 40 to 60 pounds a megawatt hour, it's then got some heat which is effectively free, other than for the cost of piping it to wherever you want to use it. And then it's got some heat where there's flexibility to divert more heat before it hits the turbines and then make less electricity. And the cost of that heat, and therefore the cost of the hydrogen, is something which we are looking at, but which will essentially depend on the cost model that the government prefers for the nuclear power plant construction. What we're thinking about with the government is the idea of being paid to have built the kit and having the electricity owned sort of pretty much in the consumer interest, so the electricity is sold to actually essentially benefit consumers. And we think that if nuclear comes in at 40 to 60 on the basis of a regulated asset base, then we think that actually it will bring consumer bills literally down, because it's an awful lot cheaper than storage and provides all sorts of additional services like inertia, which will otherwise be turned into contracted services. So that's a very long way of saying we don't really know, because it's all about how the government chooses to finance nuclear, but we're pretty sure it's going to be very competitive.
Carl, do you mind me joining in and asking Julia a question? Am I allowed to do that?
Absolutely. There's no rules. There's no rules, as you've seen with the technology today.
I mean, a question for me is, if I look at the French model with EDF and their subsidiary Hynamics, the subsidiary model there is not high temperature electrolysis, which has to run at a very high capacity factor. It's low temperature. And the reason for that was not because of efficiency. You could use a solid oxide electrolyzer and in theory have a higher efficiency. And I know you've referred to the Sunfire project in Germany. But they do it to balance and grid follow. So their logic is, rather than having to ramp up and down the nuclear site to respond to changing levels of output from wind and solar in the French grid, it is far better to be able to take extra capacity coming off the nuclear, and rather than feeding it into the grid and having to pay the grid for those additional costs of integrating renewables, the electrolyzers can take that. And then by selling it as a mobility solution where it's already displacing a more expensive fuel, you have a more attractive commercial proposition that doesn't need price support. So, is that part of your thinking as well, or have you got a different approach? And if so, why? Because it didn't really come up in the discussion earlier, and I just was curious to see why that was the case.
So at the risk of not really answering your question, it really depends on what the government wants the nuclear for. It needs it to make electricity when the wind's not blowing. It has masses of heat as well. And so the electricity system can either be constructed with nuclear sitting as a base load, running constantly, chucking out maximum electricity, or the nuclear can be asked to load follow, or the nuclear can divert electricity and heat to hydrogen production when it's windy. If I were designing the system, I would do the third of those. But it is something which we need to agree with the government.
Perfect. Mark, I'm going to put you on the spot because you mentioned it during your presentation, but the site has been scaled up on 2 occasions already. And I just wanted to, just due to the material that we've been covering today, to give an insight to the attendees on just how that process went about, and was there anything unforeseen that arose, and is there plans again for upscaling? And I know you addressed the issue from land resource side. It is just your normal, well, to Joe Soap, to myself, of a refueling station that I know and have been born and raised with. But I'd like to get your insight really on that, of one, when the decision process was made, for upscaling, and then what was involved.
No, absolutely. So yeah, the decision, so we'd seen what the introduction of hydrogen buses had done to Aberdeen and to the general awareness, and as you always hope for, it generated inquiries from third parties saying, we now know there's a Toyota Mirai available, we now know that you can create dual fuel refuge collection vehicles, road sweepers. We know all these new things are coming along. We've got hydrogen there. Can you accommodate these vehicles if we wanted to invest and decarbonise? And with the way the station was designed, we said that we could. Like you're saying, you factor in those number of vehicles, and you'd say that's still within the tolerance level. You're not losing all that design redundancy. And with a relatively small investment of an additional dispenser and some high pressure storage for the 700 bar, we can then accommodate those additional vehicles. That was also in conjunction with the second station that was built in Aberdeen, which is operated by the council itself. So we were able to share that, which reduced some of that sort of limitations. But size-wise, we're like saying, we consume most of that available space currently, and there is we're at capacity on the grid as well at that location. So one thing we're looking at is, for more vehicles, do we look at maybe introducing delivered hydrogen to the site from either locally produced or as part of the wider scheme in Aberdeen? Or do we say, this has been really useful, it helps us, we're going to keep this going, but for larger deployments of bus fleets, for example, why don't we do something at the bus depot, or something more specific where you design in that flexibility, and you then look at that and say, if you were going to convert all your bus fleet, how many would be battery electric and how many would be hydrogen? And you sort of, like you're saying, you design it with the footprint for the maximum capacity, so that you make sure you've got that. And in your utility connection, if you need 2 MVA but the end is 4 MVA, you would apply for 4 and have 4 MVA, just so those things don't become expensive down the line, that you've got those basic things, footprint and electricity capacity. And then, like you're saying, the design is modular, so then it's the introduction of additional storage dispensers, and then at some point it may be additional compressors, for example, or electrolysers. So it's really important to plan for that future space. And with, like you're saying, with Kitty Brewster, it was only ever conceptualised that it would be 10 buses, but now it's a lot more than that. And like you're saying, with having that foresight to plan for additional, you're able to max out the design, and then then that the next conversation either takes you somewhere else, or you invest more on that site in future.
Bird, and that leads me in, Chris. I'm going to put you on the spot here, because what are the sticking points from your perspective? And you can wear your hat as a CEO or from the society's perspective on when you're advising your clients, or when people are approaching you about hydrogen projects. When you sit down to them, what are you saying? Look, here are the sticking points. Is it the regulatory side? Is it the government side? Is the finance side? Or is there any sticking points? Let me rephrase.
Yeah, so I mean, I think where we tend to look at it is, as I said, so our model is essentially around building dedicated assets and dedicated facilities initially for an anchor client, right? So from our perspective, if you want to do dedicated renewable production, the most common challenge we actually have is a land constraint one, is figuring out where actually is the land to develop assets. That is probably the single most important consideration. And to be honest, that's why many other developer models don't bother going down the route of developing the renewable assets themselves. They already partner with an existing developer of renewables that has an existing asset. Now, the challenge, of course, there is a regulatory one, right? Which is why you're kind of having this interesting back and forth, where the regulatory structure as it exists in the UK and the policy framework is set up to reward people who go and build additional renewable energy. Because to Julia's point about what's the government wants, Sizewell to do, well, there's a little bit of a similar conversation going on within the hydrogen industry, saying, well, what do you want us to do, right? We can put down a lot of electrolyzers, a lot of refueling stations, but if everything has to have its own dedicated renewable energy facility put in, that will obviously take longer. Mm-hmm. And I think this is where people look at the sort of story of the EV charging industry, and they try and look at that for parallels and say, we didn't mandate initially that every single EV charging station had to be set up a certain way to get them up and running. Now, that doesn't mean that was the right approach. That actually has had a lot of criticism. So, there's a back and forth on it. And there are now sites like the UK's first EV charging forecourt that was just opened last week, that has its own rooftop PV and batteries, and it's got a dedicated additional solar PPA from a field they've done. So I think when we then sit down with clients, it really is just ultimately getting down to what is the main reason you're doing this. If you're doing this because you want to be cheap, you're trying to get a cheaper solution than what you already have, there's a very different set of considerations to, we want to be net zero and we want to evidence unequivocally that we are 100% renewable. You come to very, very different outcomes. And so in that sense, it's very much a client-centric approach for us. I think on the bigger hydrogen scale thing, it really is that lack of certainty of how ambitious the government wants to be. The UK will have its 6th carbon budget from the Committee on Climate Change tomorrow. There will undoubtedly be some sense of where they see hydrogen's role within that. There's the government hydrogen strategy in April. There will also be further clarity on that and what they see as, how are we going to get to this 5 gigawatt number that was announced by the government, and what does it look like after 2030? What's the sort of 2040 target, 2050 target? I think those are kind of at the macro level really critical questions, because if you're trying to think about an integrated system approach, which is the cheapest way to net zero and is ultimately the best value for all consumers, there needs to be a joined up strategy. And at the moment, there isn't one. And so that is why projects tend to be very unique and bespoke to a specific set of context in the current market. But as the market evolves, and there is a clearer sense of where the structure and where the policy framework is pushing everyone towards, you will see more sort of general, I guess, comments and challenges around the development of the market, as opposed to, well, this site has this constraint and this site has this constraint, which tends to dominate most of the discussions at the moment. And Mark, I don't know if you disagree with me on any of that. Obviously, it's slightly different. I would say BOC's got a probably wider array of project experience than we do, as we just do green hydrogen and Mark. So.
Yeah, I genuinely agree, Chris. And I think we're starting to transition out of that very bespoke model, because people are understanding that hydrogen at scale and the economics and the models for doing that. But fundamentally, like saying, a lot of it is around the customer saying, I've got this requirement, and then it's saying, right, well, we can do it like this, but and it's like you're saying, it's that the cost versus availability versus efficiency, all those things. You can play numbers with that and do it for the client, and the client has to accept that. But like you're saying, when you're going into a fleet operator, then availability is going to be really high up there on the agenda. They can't treat it like a demonstration project. It's a commercial proposition. It's a fuel switching program. So yeah, I think I absolutely agree with what you say. It's like you're saying, it's driven by the client, but we need it to be driven by government now as well to sort of get that along the road.
Yeah, I mean, this is almost part of the junior cost of capital problem, right? Which is that I can get my lowest cost of capital and lowest cost of hydrogen when I have dedicated fixed offtake, because I can project finance it and I can get a lower cost of lending. But if I want to build an optionality which allows me to supply more than my original market, I can't project finance. I probably have to have a much bigger equity portion in that capital stack. And at the moment, that equity is expensive, which is where grants have typically come in, because it can give you that optionality. Whereas without that, you're going to start immediately either with a much worse commercial return, which for most companies, unless you really have a strategic market development perspective, you can't justify to your IC, or ultimately you're just going to limit the constraint on what you can do down the line. And there are parts of policy that are perverse in the UK. If I don't connect my renewable energy asset, if I built a solar or wind farm as Protium and I don't connect it to the grid, that is better for my commercials than connecting it to the grid. That doesn't make any sense to me. I should be able to connect it to the grid, and the system operator at the grid level should be able to say, right, I'm going to take your solar and wind today, and then your electrolyser, if you tell me what your capacity factor is you need it to be, we'll find a way to make that happen. That is the best way to reduce cost for everyone, but it doesn't work that way. In Germany and Austria, it does. They've just changed the regulations now in Germany and Austria and waived grid connection, not grid connection fees, sorry, they've waived the fees on grid services on electrolyzers. So if you're paying, 13 euro cents a kilowatt hour as a regular consumer of electricity, you're now paying 7 euro cents a kilowatt hour. That is absolutely transformative. Suddenly, it completely changes the nature of your economics, and that is an entirely government decision. And who pays for that, right? Does that cost get passed on to other users of the power network because the government doesn't want to pay for it? Does the government pay the power network users for that? That's also a much bigger piece and a conversation around net zero and the transition, which is why Mark is right. Ultimately, to move into that bigger dialogue and that scale up, there has to be a government view on what role do we want all these different technologies, nuclear, hydrogen, CCS, to play, and then how are you going to restructure the regulatory framework so that who pays is clear between the parties, because it's not at the moment.
And I think the key risk is that you almost bring in a risk that you limit your clients' ambitions as well, the end users, because cost becomes a bigger factor than it needs to be. They're being driven down a road, but like you're saying, there's a pressure point, isn't there, where you want them to be able to transition everything and be able to deliver that using mechanisms to get that to where it needs to be, and then it'll snowball in a big way. It will.
So should we collaborate in pressing for an independent system architect to actually assign roles to technologies, and then everyone can make sense out of the system?
Julie, you took my next question, which is quite frustrating.
Well, in that case, the answer to your next question is yes.
Yeah. My question was going to be, well, we've got one from the attendees, which I'm going to get off, and that is for Sizewell, so Julia and Shekhar. is Sizewell considering the technology risk on the combined basis for EPR reactor and hydrogen with respect to 1, delay on construction, and 2, appetite for new investors to join Sizewell C, both from the equity and debt perspective, if bankable?
So there is no technology risk to the building of the UKPR. All we're going to do in terms of building the UKPR is put in valves to take out the heat before it hits turbines. We know that we can do that. It's already, those same valves are already in place, in fact, in one of the French reactors. So then there's the question about really it's an economic question. Do the future owners of Sizewell, because EDF itself only intends to retain a minority stake, do the future owners of Sizewell want to use that heat to make hydrogen? We think they will. We think it's a significant additional benefit, and we think, in fact, that a plant which you can use flexibly for heat or grid-scale electricity or electricity for things other than the grid, we think that is a pretty much future-proof asset, because whatever the future of electricity production, which is something on which many people have views about, are we all going to get our electricity ultimately from Moroccan solar or whatever? Decarbonised heat is definitely going to be something that we need, and hydrogen looks like it's got a great future in the UK. So I think it's going to attract additional investors as being a diversifiable and future-proof asset.
Thank you. And then we're going to touch back on the system design, because I think, Julie, your slide presented it perfectly on the flexibility required in the network, but also the constant power threshold. And as we'll have all have seen on the 6th and 7th of this month, low wind, exceptionally low breeze, and of course very cool temperatures. So the demand has been extremely high over the last number of days, and the prices have reacted accordingly. And my question really is, from the nuclear aspect, the green side, and then Mark, if you want to just put on the consumer hat here, what do we do with the grid, and how do we deal with that in the short term? Because clearly there has to be changes made in order for this to get the right price to the consumer, and then from the developers to have that certainty.
Well, we hope that the energy white paper will set out the desired energy mix, and that the grid system will be adapted to that desired mix. As you say, we absolutely have to keep costs down for consumers. Some of these costs will fall on the people least able to bear them. Yep. And I think making the energy transition affordable is an imperative for all of us. So hopefully we're all looking forward to the energy white paper.
I think the masses will agree with you on that. And then, appreciating we have 2 minutes and we will finish on time, my final question for the floor is stakeholder involvement. Some people will question, the safety around hydrogen. And Mark, maybe you could start with how BOC has dealt with that, and then if Chris and from the Sizewell team, do you want to conclude? Just because we feel it's from the side we're seeing with the clients is that the stakeholder involvement is very important, but it is a very live issue.
No, I agree. And the one thing I will say is that we have started to talk less and less about the Hindenburg, for example. There's a lot more general awareness about hydrogen now and how it benefits. And it's having the right people, like saying, we all have to follow procedures. There's standards in place for how we build. There's refueling standards for hydrogen. It's a controlled environment, and like saying, hydrogen's like saying it's a flammable gas, and you have to respect it that way, and that's why it's very well controlled. So the safety aspect is like saying we are adhere to safety distances, control what they call SIL loops. So all these safety loops and all the mechanisms that happen if anything happens to minimise anything. And they're being built and they're being operated for numbers of years, and again, they've got a good safety record. And we probably scrutinise more because it's something new, so we're probably having to do more than's been done in the past. But we're comfortable doing that. Like you're saying, there's plenty of businesses out there wanting to produce hydrogen, the infrastructure to bring the vehicles along, and we know that we have to do it in a safe manner. So hopefully by being able to kick the tires and see the data, etc., can give people confidence that it is a safe fuel for the future.
Yeah, I don't know if there's 30 seconds. There's 30 seconds to say is for stakeholder engagement. I think half the key is seeing is believing. So Baroness Meacher, who spoke in the House of Lords recently, drove a green tomato fuel cell vehicle to the House of Lords because then you actually can see what they're like. And most people have never seen what an electrolyser actually looks like. There you go. If you haven't, you know, people haven't actually gone and seen these systems. It makes such a huge difference. And I think it's only through deployments and getting people familiar to go and touch and feel and walk around these facilities that you're going to build that stakeholder engagement, whether it's investor, politicians, public, or clients. But ultimately, I do think the biggest group that drives this will be actually younger people, whether they then go into investment or policy or consumers, but they're going to drive it. And if they understand it and they see the role in the transition, then it will happen. I have no doubt of that.
Shekhar, any closing comments?
No, just to say that I fully agree with what Chris and Mark just said. And as a matter of fact, even in context of Sizewell C, the number of discussions we have had with just such a wide range of stakeholders, it just bears out that point that the breadth of engagement that needs to take place, as in just in terms of informing, educating them, in terms of where we are, what we're trying to do, what is it exactly that could be achieved. And just to give one illustration, actually we have a funded project, which is funded by Innovate UK, ongoing at Sizewell C right now, looking at the transition of the fleet as Sizewell C in the future from being powered by diesel to being powered by hydrogen. And something like that, as in just clearly shows that there is a lot of interest in what exactly that future might look like. And that interest is growing, and it's probably up to all of us to ensure that we manage to, you know, like capture it and like drive it in the right direction. And hopefully that will be the tone in the years and decades to come.
Lovely. Thank you. Ladies and gentlemen, that brings to an end our second and final hydrogen online seminar series for 2020. Hopefully you found the last 90 minutes or so as insightful as I have. A lot of issues to take away from this and a lot of issues to look forward to at all levels. And I'd like to thank our panelists once again for joining us today and for all our attendees and their questions that they've sent in. Chris, Mark, Shekhar and Julia, thank you very much for your time, much appreciated. And from a sign off from everyone here at Stephenson Harwood, it's a Merry Christmas and a Happy New Year.